Continuing with the moment of a couple, in the moment of the couple, the distance vector r dash is actually r2 minus r1. Okay, the distance vector r dash, which is r2 minus r1, is actually the distance vector between the lines of action of the parallel forces. So if you have two parallel forces acting, and if distance r vector is the vector which is the distance vector between the two forces, then the distance vector r is obtained as vector r1 minus vector r2, which is actually the position vectors of the two forces F1 and F2. So there are two parallel forces. The parallel forces are F1 and F2, and if r1 is the distance vector of F1 and r2 is the distance vector of F2, then the resultant distance between F1 and F2, which is r vector, is actually vector r1 minus vector r2. This vector is called arm of the couple. So this vector is actually the distance vector between the two forces, and the two forces F1 and F2 are actually making a couple. This is F1 and this is F2, and then the perpendicular distance vector, if it is vector r, then we say r is called the arm of the couple. Direction of the moment is a vector perpendicular to r and force F. So the direction of the moment vector m is a vector which is perpendicular to the distance vector and the force vector F. So it is actually a three-dimensional quantity. So vector F will be in a direction, vector r, the distance vector, will be having another direction, and the direction of the moment vector m will be in a direction which is a vector direction perpendicular to both the force F and the difference vector r. Now we are going to classify the different types of forces. The first type of force is called a concurrent force system. A concurrent force system is a system where all the forces are meeting at one single point. Okay. So if the forces are meeting at one single point, let us take that the point is O. Okay. And if all the forces are meeting at one single point O, then we say the forces are actually a part of a concurrent force system. Thus there is no resultant couple moment, and the resultant force act at the specific point O only. So if all the forces are meeting at a point O, then there cannot be any moment. So the moment cannot be developed because there will not be any perpendicular distance between the forces, because the forces are meeting at one single point O. But there can be a resultant force, and the resultant force will be acting at a point O only. So that is what is called a concurrent force system. So if we are going with the coplanar force system, then the forces lying in one single plane. If all the forces can lie on one single plane, then such a system of forces is called a coplanar force system. Now such a system can be represented by the resultant coplanar force F acting at a point O. So we will have a resultant force F acting at a point O, because all these forces are lying on a plane, and the resultant moment M will also be existent along the axis passing through the point O and a normal to the plane of forces. So this can be further simplified by a resultant force Fr acting at a distance d from the point O. So for a coplanar force system, we will have a resultant force and we will also have a moment. But for a concurrent force system, we will have a resultant force sigma F, but there will not be resultant moment. So resultant moment will cancel. For a coplanar force system, we will have a resultant force and we will also have a resultant moment. So that is the difference between concurrent force system and coplanar force system. Now we are going to discuss the concept of equilibrium. So discussing the concept of equilibrium, we are going to discuss two different points with respect to the topic of equilibrium. If any system of forces keeping a body in equilibrium, then the algebraic sum of forces in any direction is 0. Okay. So if you have a point O, and there are a system of forces acting at a point O. Okay, there are a system of forces like F1, F2, F3 and F4 acting at a point O, and we say that if the point O is said to be in equilibrium, if we say that this point O is in equilibrium, then the algebraic sum of forces in any direction is 0. So that means sigma F of the system of forces in any direction will be equal to 0. So if this is the case, then we will solve these kinds of problems by using the technique sigma f of x is equal to 0, sigma f of y is equal to 0. So this is the technique by which these kinds of problems are solved, in which we have a system of forces, and the system of forces are keeping a point or a body or an object in equilibrium. Then we can say the algebraic sum of forces in any direction is equal to 0, and if algebraic sum of forces in any direction can be taken to be 0, then we can say sigma f is equal to 0, and more specifically we can say sigma along x direction is equal to 0 and sigma f along y direction is equal to 0. So these kinds of problems coming in category 1, solution can be obtained by doing sigma f of x is equal to 0 and sigma f of y is equal to 0. And about the second point, for any system of forces keeping a body in equilibrium, algebraic sum of moments of all the forces about the point in their plane is 0. Okay, here again we have a system of forces keeping a body or a point in equilibrium. Then we can also say that the moments of the forces at any point is equal to 0. So you can expand the net system of equations with respect to a moment also. So we will get sigma f of x is equal to 0, sigma f of y is equal to 0, and sigma m at any point is equal to 0. So the questions can be solved by using the technique. This will be the technique. So such problems will be solved if you are going to find the solution for sigma f of x is equal to 0, sigma f of y is equal to 0, and sometimes if it does not solve with the sigma f of x is equal to 0 and sigma f of y is equal to 0, then you will have to find the moment also at any one single point given in the system of forces. So the net expressions, the net equations through which a system which is in equilibrium can be solved is sigma f of x is equal to 0, sigma f of y is equal to 0, and sigma m is equal to 0. So these are two very important points, and this is to be remembered when we are going to solve problems. This will become handy. And now we are moving into free body diagram. Free body diagram is a technique in which the associated environment of a body is changed, and if the body is also working in a system of objects, like if it is a connected body kind of an arrangement with a pulley and a chain and a string, we will be isolating each and every body, and then the body will be represented as a single body with only the forces acting upon that single body. Then such a diagram is called a free body diagram. So this is applicable in the case of connected bodies. This is really applicable in the case of problems for the solution of problems which involves friction. And this is also applicable in problems where there will be a stack of objects kept one above the other. Like the pipes are connected one above the other. You will be having two pipes, and above the pipe another pipe will be connected, and not connected, it will be kept. So this is a combination of bodies, or this is a system of objects. So the system of objects has to be split into single free bodies, and then only the forces acting on the single free body will be represented for our easiness of solution. So this is applicable, free body diagram is applicable for friction, free body diagram is applicable for objects kept one above the other, free body diagram is applicable for questions dealing with the connected bodies also. Connected bodies in the sense the bodies can be directly connected, or the bodies can be connected through a chain and pulley arrangement. Okay, so as an example I have put this free body diagram, in which you can see that this is the